This is Harold Waters again, Field Specialist for Agronomic Systems for OSU Extension. Talk about nitrogen in Ohio and really trying to think about how we can manage it. And I think we need to know a few pieces of background in order to think about how we should manage nitrogen. So what about the fate of nitrogen in Ohio? Slide here shows the nitrogen cycle. And I know that folks kind of glaze over their eyes whenever I talk about it, but I think we need to know not all, but many of the impacts that may have on our nitrogen. Number one, nitrogen is certainly the largest amount of gas, not element that we have in gas in the atmosphere. 78% or so is nitrogen, but none of that really is available for plants except what may come through rhizobia in a legume system. So it is a slippery element. A lot of things work on nitrogen. The weather, certainly above ground, has a great impact. And then below ground, and I have it grayed out here, those soil dwellers, soil mineralogy, clay in particular, has an impact on nitrogen. So great losses potentially for nitrogen and lots of interaction. Point out also on this slide that up until about 100 years or so ago, legumes nitrogen and manure nitrogen was really the only two ways that we got nitrogen for a corn crop or for any crop for that matter. And then in about, well, I think it was 1908, the Haber and Bosch process became available to create artificial nitrogen, and that is the greatest input for nitrogen today. A little bit more maybe here, think about it in the nitrogen cycle, and I think about it as additions and removals. We apply on average about 160 pounds of nitrogen to our corn crop across Ohio. Mineralization, that's the nitrogen released from our soils. We may get another 50 to 70 pounds of nitrogen, giving us about that 220 pounds of nitrogen additions per acre. And beyond that, we may get a little bit from lightning. Certainly we do maybe 15 to 20 pounds as well. Removal, crop removal of nitrogen and grain is our biggest removal, maybe around 100 pounds of nitrogen per acre. Other losses in leaching, I'll show you a slide here in a second, but 25 to 30 pounds of nitrogen per acre is perhaps what we have on average. And in denitrification, that's the change to a gaseous form, perhaps 40 pounds of nitrogen per acre. And that can be larger or less depending on the year as well. So a few more thoughts here. This is from a NRCS technical bulletin. I like how they put it in perspective, just to think about other losses that we may have for nitrogen. Immobilization, another big one. That's organic forms that tie up some of those ammonium and nitrate forms. 10 to 40% loss from the system. Erosion, depending on where we are, how our slopes are, maybe 0 to 20% loss. Volatilization of both ammonia or urea, maybe 0 to 30% loss. Leaching, and that's what our greatest concern here is in Ohio, because what goes down in the water ends up showing someplace else, up in a lake or a pond, something like that. But 0 to 20% loss there from leaching. Denitrification, 5 to 35%. If you take that column on the right side, those add up to about 150% loss, and certainly I've had some farmers tell me they feel like they've lost more than everything they put on. The other couple of quick notes across the bottom there the tech sheet points out, maybe 40 to 70% of our nitrogen fertilizer ends up in the crop, so a little less than we think certainly. And then nitrates remaining in the profile after the end of the cropping season, which may be that 50% or so, is lost over the winter due to leaching or denitrification. And then finally, our last slide here, just a quick report on some of our edge of field study results. Shows that yes, we can lose very significant amounts of nitrogen, certainly approaching 100 pounds of nitrogen per acre. And put a second line on there at 50 pounds of nitrogen per acre, showing that yeah, we have a loss of easily that 20 to 30 plus pounds of nitrogen and nitrates that leave the field in the form of water, with water, I should say.